Today I want to address a pretty common issue with old tractors, and that's one of lights that don't work. Now, I'm pretty sure I know what's wrong with the lights on this tractor because they were working and then suddenly they weren't. But just for the sake of this video, I want to go through and show you how to troubleshoot your lighting system and get them going again. So stick around. We'll get these lights back on this 140, and hopefully that'll help you solve the mystery of why your lights don't work on your tractor. So fortunately, the lighting systems on these antique tractors are pretty easy to navigate. There's not a lot to it, and you can see I turned the switch on and there's nothing there, no juice. Now there's not a lot of components, so I'm going to show you really quick what the components are of these systems. First of all, you got your light switch, and it'll most likely be something like this, and it doesn't matter what color you have. They pretty much all have the same light switch. So here you can see I've got off, dim, bright, and reverse. Some of these lights might have had a switch on them. You'd have half of it would be like a red bulb in there, and then there would be a white light. And with that switch, you could toggle between the two different lights. And that was pretty much the only tail light that was involved in a lot of the old tractors. Like my Super C has one of those. But when you start getting into the 60s and 70s, they started having these flashing lights and a little bit more wiring. You'd see a relay like you see down here attached to the seat. That was pretty common. You've got a fuse, usually one fuse that run the whole system. And then of course you've got the wiring harness, which runs down the length of the tractor, and usually up here somewhere it'll split, and then it'll come in here. You'll see different styles of lights. Some are flat backed, some are teardropped, and this is a 1973 bulb or light, and it's got a whole different connection on here. Instead of what you would typically remember would just be one screw terminal with a hot lead, and then the ground would just be this whole mounting assembly. Some lights are independent of the key switch, so sometimes you have to have the switch on and the lights, and other times you don't. To test your lights, you're going to need either one of these test lights here that's got a probe on one end. So with a negative ground, you would ground this end out. You would just attach it to some part of the frame, and then you would touch this end to what would supposedly be the hot, which would be the positive. I generally use a multimeter, and a lot of times with these fuses, they will be pretty obvious when they're blown, but not always. So I'm going to separate the fuse from the holder. Now with a multimeter, the way you would check a fuse is there's a little setting right here called diode check, and so if you put that down there, it'll be overload, and when it's on overload, that means you've got an open, and then you would take these leads, and if you cross them together, you'll get a beep, and what that shows you right there is that you've got connectivity. So in theory, when you do this, you should also have connectivity, and you can see that I do not. So if you connect these together, connectivity, put in the fuse through, no connectivity. And you can look at this fuse, and you can see that it looks like it's good, but it's not. And just replacing the fuse sometimes will fix it, but a lot of times it'll immediately blow. And so we need to go troubleshoot the system and find out what is causing this fuse to blow. And what most often will cause a fuse to blow is a short to ground. What a short to ground means is that you've got electrical current passing through a wire, and at some point that wire has some sort of defect in it that is causing the electrical portion to hit the chassis of the machine. And when that happens, it overloads the circuitry and a fuse is blown. Now when you look on this, and it's so small that I can't zoom the camera in enough, but you would see that this is a bus. Bus is just the name of the fuse company. It's a glass fuse, and they have all different amperages that they're rated for. Some are slow blow fuses that actually look a little different, and it takes a little bit more of the defect to be prolonged for them to blow. And what that means is sometimes you'll just have like a short interruption and the fuse won't blow, but if it's a delayed or an interruption that lasts for more than a second or two, it will blow the fuse, and those are more expensive. But this is just a regular old AGC 15 fuse. Now you can go on Amazon and get yourself a whole slew, a package of different size fuses. They come in different sizes. Sometimes you'll get the ones that are like half as long as this one, and those aren't going to work. You need to replace it with a like fuse. You can always replace your fuse. So with a 15 amp fuse, I could always put a 10, a 12, a 5, a 3. They'll just blow faster. What you can't do is put like a 20 in there. You can't take a 15 amp circuit and put a 20 amp fuse in, because what you've got now is you've got a fuse that's going to blow at a higher rated amperage than the system is designed for. So if you've got any kind of fault in there, one of your electrical components might take that, like your light bulbs or your switch, and you could even cause a fire by having a fuse that's incorrect. So, and by no means ever take the fuse out and put like a nail in there, or I know it sounds stupid, but people do it, and I wouldn't bring this up if it wasn't something that happens. So never replace your fuse with anything except the fuse that was taken out. An exact replica of the fuse that was blown is what you need to replace it with. What we would do as technicians is they would do what they would call a half split method. So somehow you would try to get in the middle of your system, and then you would check it back towards the source and check it towards the equipment end. So the equipment end is your lights, power is your battery. So the power's going to go into your switch and then be distributed out to your lights. The easiest way to do this with a tractor like this is to unplug your lights, which is usually pretty simple. And then you would take your meter and you would turn the switch on and see if you've got power. Power all the way to your lights. You can tell it's your light that's problem. If you don't get power to your light, then you know your wiring is problem. And you can, at some point, you might have to take the switch apart and check it there, but I don't think the switch is the problem on this tractor, so we're not going to get into that. Pulling the switches out of these tractors, it's a little bit of an endeavor because you have to unhook some stuff, and often as not, you need to take the battery and the battery box all out and unhook everything, and then feed it back out through this way, through the engine side or the firewall side, check all the components, put it back in, and then put the knob back on, because that's just how it detaches. It attaches this way and not this way, if that makes any sense to you. So hopefully we don't have to get the switch apart. And I have a video on that with my Farmall 1955 that we did. So if you want to know how to work on your switches, I'll put the link to that in this video as well. But what we're going to do right now is we're going to check these wires. And unfortunately, when they made these machines, for whatever reason, they used a lot of metal, and they didn't put these in any kind of a raceway. Now these clamps right here, at some point had some kind of rubber material on them to protect the wiring, but that's kind of worn away. And what I can tell with this tractor is that the cultivators, when the cultivators are lifted, and the way this works to lift it is forward, and this little rocker here picks it up. When it goes forward, it hits on the light bracket here, and it hits the wire, so I can see the wire is broken. So an easy way to troubleshoot first is you just look at the system and see if you can find something that's visibly broken. And with this tractor, yeah, it's visibly broken here. That piece of metal is grounded to the chassis. When that hits that, it's worn the wire through. That's created a short to ground, and most likely my issue is right here. So let's see if we can fix it with you on camera and get the lights back in operation again. They put the wiring on these tractors and then they painted it so all the wiring is red. Now that's not super helpful. You can see right here I've got 3 wires coming to it, and that's for the high and the low beam and the ground, so they're all going through this one thing. What I need to do is get these clamps off so that I can access this wiring, and that's really like banjo string tight right there, so they didn't give you a lot of extra wire to play with, unfortunately. And you can buy some sort of clamp replacements like this. I've seen them, but you can see inside here that's all garbage, and the insulation's all worn away, so that's garbage. A lot of times with these, they just stop working because they've got corrosion at the contact points. So all the connectors would be one of the next things. It's not the fuse. You could open up the lights and check the light bulbs and see if the bulbs are good. And if those things prove to be true, then the next thing I would do is I would start looking at all the connections. And I can see these are all worn right through. Now when you can get this off, I can see now that I've got a red, an orange, and a black. Normally, red is hot, black is ground, and the orange would be your alternate power. So the alternate power would change it from a high to a low beam. And there's just not any extra. So it's all coming in behind the generator. But here's my main wiring harness. And these will get dry and crack out. And a lot of times people have hacked into them for whatever reason. This one's in pretty good shape, and I hate to cut it into it, but unfortunately that's what's going to happen. So we're going to remove the connector. And what we're going to do is we're going to cut and splice in a new piece of wire. Now I could, in theory, not connect it. I could just cut it and have it hanging across here, and that would probably be correct. I don't think it's going to get hung up on anything as long as it's up high enough, but what I don't want is this to continue doing what it was doing. So a good idea would be to somehow move this wire to the front and then come around out to the outside and back in. Just like the fuses, you don't want to replace your wires with a different gauge wire than what you were already have in place, because a smaller gauge wire, think of it like a pipe. If you've got a small hose, you can only get just so much water through there. And the same thing is true with wiring. If you have a small wire put in the middle, you're going to take more voltage to get the current through. So the voltage is what gives it the push, and the amperage is what actually is the power, and the resistance would be the smaller wire. So you're going to need more power, more voltage, because you've got increased resistance, and that's going to result in less current being shoved through there. So just a little quick lesson in electronics. So in order to do a quality job on this, we need to have quality replacement parts. So what I'm going to do here is, this is the red. I'm going to snip it just a little bit on both sides of where the fault is. And these right here are, I call them self-stripping or self-adjusting wire strippers. So what you need to do is figure out what your gauge is, and you put it in, and then you open it and take that off. You can get super fancy and you can tin your wires with the soldering gun. These mechanical crimps will last quite a long time if you do it correctly. So we got this back on, and that's not going to interfere with that anymore. I tested this before I closed it all back up, and I encourage that before you button everything back up that you test it and make sure it works. And then after you button it up, obviously test it again. I hope this has been helpful, and again, I'll put a link to the switch wiring in this video as well. If you have any questions or concerns or comments, as always, I love to hear them. I appreciate you watching, and I will talk to you next time. Happy New Year.